Hi, welcome. This is Regina. In this video, I have a few problems on functions. Before I show you the problems, let's review some of the rules for the function. A function or a relation is said to be odd if it is symmetric about the origin. For example, if the graph looks the same after it's been rotated 180 degrees about the origin, and this can only occur if f of x is equal to negative f of negative x. An even function is a graph that is symmetrical about the y-axis, such as a graph like this. And this can only occur if f of x is equal to negative x. When do you factor quadratic equation? I recommend you always figure out the discriminant when you're taking 2C math. Not all quadratic equations can be factored. Only if the discriminant is perfect square, then you can factor it. Otherwise, you will have to use the quadratic equation. Couple of other reminders. When you have a polynomial divided by a divisor and you have a quotient, remember, you can multiply the quotient in the divisor to get your original polynomial. Also remember, you can never square root a negative number, and you can never have 0 in the denominator. Alright, so with that reminder, let's go straight into our problem. I'd like you to pause the video now and do this problem. You can run the video again for the answers. Okay, so the question is the function of f of x is equal to 1 over square root of x, and it's defined by all x values greater than negative 1. Write an expression for the inverse of this function. So the inverse of this function is simply trading x and y values and solving for y. Because of the square root, I simplified all the way and then I traded my x and y at the very end. Simply squaring everything gives me y squared is equal to 1 over x plus 1. X plus 1 is equal to 1 over y squared. X is equal to 1 over y squared minus 1. And I treat this as a fraction. That's 1 over 1. So the lowest common denominator is y squared. Y squared goes into y squared 1 times. 1 times 1 is 1. Minus y squared divided by 1 is y squared times 1 is y squared. So this is what x is equal to. Remember, with inverse, we switch x and y. So the inverse function is 1 minus x squared over x squared. So you can see we have two choices here. 1 minus x squared over x squared, and we have 1 minus x squared over x squared. The question is, what is our domain for the inverse function? Very easy. Remember that the range of the original function becomes the domain of the inverse function. So the range, as you know, is the y values. And since you can never have a square root of a negative number, the range will always be positive. So you want the domain of the inverse, meaning the range of the original, to be positive, except you cannot have 0. So x should be greater than 0, and the correct answer choice is A. Moving on to another question. Okay, pause the video and make sure you run the video after you've done the problem. It is very, very important that you have thought about it very seriously. Not any of these questions are never as easy as they look, and they're certainly nothing like what you see in your algebra textbook. So please pause the video now. Okay. Which of the following could be g of x? So which one of these is g of x if f of x is given by this equation 5x squared plus 4 and f of g of 3 is 84. So I know f of g of 3 is 84. Consider f of g of x. That would be 5g of x squared plus 4. Now consider f of g of 3, which is 5g of 3 squared plus 4. 84 is equal to 5g of 3 squared plus 4. Subtract 4 from 84, you get 80 is equal to 5g of 3 squared. And then dividing by 5 gives you 80 divided by 5, and you get 16. So 84 minus 4 divided by 5 is 16, and that is g of 3 squared. Square root both sides, and the answer is plus or minus 4. Question is, which of the following choices could be g of x? Now you know g of 3 must be plus or minus 4. All you need to do is plug 3 in each one of these and see which one would give you plus or minus 4. Testing for A. 3 4s are 12 minus 10 is not 4. 4 3s are 12 minus 7 is not plus or minus 4. Nor is 6 times 3 minus 17. X squared, which is 3 squared minus 5, indeed gives you 4. And 3 squared is 9 minus 3 does not give you 4. So the final answer is D. Okay, we're now going to move on to the next question. Please pause your video and do this problem. After you've done the problem, run the video. Okay, let's go ahead and read the question. F of x is equal to x cubed. Which of the following must be true? It's an odd function. This is x cubed. F of negative x is not equal to f of x. Otherwise, the graph would be going this way. F of negative x is negative f of negative x, which will flip it back out again. F of negative x is equal to negative f of x. Well, that makes sense. So if you have x here, and if you have negative x here, if f of x is over here, then f of negative x is indeed negative f of x. So the correct answer is C. F of x is equal to negative f of x. Well, you'd expect the graph to swing out that way. And f of x is greater than f of negative x. It's not an inequality, so we can't accept E at all. So the answer is C. Pause the video and try this problem on your own before you run the video to get the answer. Let's go ahead and look at this. If f of x is equal to square root of x minus 1 over x, what is the domain of f of x? Well, we can't have a negative square root. So x minus 1 must be positive. So x must be greater than or equal to 1. But we can't have a 0 as x. So x is not equal to 0. So let's go ahead and look at the choices and pick the best one. All real numbers except 0? Well, not really. We can't have negative, anything less than 1. All real numbers greater than or equal to 1? I think so. All real numbers less than or equal to 1? We cannot have negative numbers. All real numbers greater than or equal to negative 1, but less than or equal, no, it's not between negative 1 and 1 at all. We can't have 0, so we reject that. All real numbers less than or equal to negative 1, again, we can't have a negative answer. So the correct answer is B. So hopefully you got B. The next question is here. And please pause your video and try this on your own. Okay, let's read the question. Which of the following polynomials, when divided by 3x plus 4, equals 2x squared plus 5x minus 3? So some polynomial, p of x, is divided by a divisor, let's call it r of x, and we get q of x as an answer. So that they're asking for which of the polynomials. Now I should do something here. There is a remainder. I want to write the remainder right here before I forget. So remember, to get this polynomial, I have to multiply the divisor with the quotient, and then I have to remember to add the 3 at the end. So I know that the quotient is 2x squared plus 5x minus 3, and the divisor is 3x plus 4. Expanding these polynomials out, I get 6x squared plus 15x squared minus 9x plus 8x squared plus 20x minus 12, and there's a remainder here. Simplifying this out, 6x cubed, 15x squared plus 8x squared gives me 23x. I'm wondering what this 2 is doing here. Maybe it is supposed to be over here. Okay, plus 23x squared. Then we have 20 minus 9, which is where we get 11x. And we have 9 here, and the answer is E. That's the correct answer right there. Great. 2 more. Pause your video and do this problem. Let's go ahead and look at this problem. The sum of the zeros of y equals 3x squared minus 6x minus 4. So 3x squared minus 6x minus 4. I want to quickly do my discriminant to make sure that I can or cannot factor. 84 is not a perfect square, so I have chosen not to factor. So x is equal to negative b plus or minus square root of b squared minus 4ac divided by 2a. b is 6, negative b is positive 6. I already have my discriminant over 6. 6's cancel out. 84 is 2 root 21 over 6. So I have 1 plus or minus root 21 over 3. So the 2 roots are 1 plus root 21 over 3 or 1 minus root 21 over 3. Plugging this in my calculator, I get 2.5275. And for the second one, I get negative 0.52752. They're asking for the sum of the roots, so I have to add them, and the closest answer I get is actually very close to 2. And the next question is the last question. Pause your video and try this. Okay, let's look at this. Find the zeros of y is equal to 2x squared plus x minus 6. Again, I quickly did my discriminant. I found that the discriminant is a perfect square, so I could factor it. And to check how I factored it, if you multiply the inner, that gives you negative 3x. If you multiply the outer, that gives you positive 4x. Inner plus the outer must match the middle term, and of course the last 2 terms multiplied must match the third term. So I know I factored this correctly. So take each factor and set it equal to 0 and solve for x. X plus 2, set it equal to 0 and solve for x. The question is find the zeros, so it's 3 over 2 and negative 2. So the answer is E. Okay, thank you very much for listening to this video. I hope this was helpful. I'll see you again. Goodbye.